Okay, team, we're back together. We're still in Unit 4, and today we're diving into Lesson 10. And so the kids have done some pretty solid work with multiplication. You've been doing the area model and also the array place value block model, but kids are solid right now in the area model. Today, what they're going to do is flip from multiplication to division. And so the good news about today is that we're really focused in this idea of multiples of 10, 100, 1,000. So you get to bring back that power of 10 language. And hopefully kids feel super successful today with division using that power of 10 language. Okay, so Carrie Bavel's at the door. And okay, she's got her keys. All right, so here we go. All right, let's dive into the problem of the day. So as we're looking at the problem of the day, it's a story problem. That means we 100% are annotating and using those academic habits. All right, here we go. You've already made a cameo in the video. I told them you were at the door. Okay, so Jose has 270 hockey cards to arrange in 9 boxes. Each box is to hold the same number of cards. How many cards should he place in each box? Story problem, do my first read through, I don't annotate. Now I'm ready to go back in and annotate and jot. Jose has 270 hockey cards, so J equals 270, great. To arrange in 9 boxes. I actually want to revise my jot to not just be J equals 270, but this is also my total. And it looks like, 9 boxes is my number of groups. Great. Each box is to hold the same number of cards. Same number of cards. Quick note right there that I'm looking for equal groups. How many cards should he place in each box? That is my big question. Let me annotate that and tell myself that I am 100% doing a division problem. So I've done my academic habits by reading my story problem, annotating and jotting. And one of the things that I jotted for was actually the operation I was going to use. So remember in the last couple of lessons, I said it was strong that network provided this space specifically for representation. It's not there in this lesson, but you just want to make sure that kids are super clear that they do that next. So the representation that I might do is this divided by this equals this. I know that always this is my total divided by a factor, which could be groups or amount in each group. So total divided by one factor equals the other factor. Now I'm going to plug in the numbers I have sort of in this KU world of things to see if it helps me out. Let's see. I know that the J equals 270, which is my total. I know that there are 9 groups. I don't know how many cards in each box. Groups or boxes. Here we go. So that's my unknown. So based on that, I come back over to my representation and I ask myself, okay, I know this is 270. I know one of my factors is 9, and now I'm looking for my missing factor. So my problem is 270 divided by 9. 270 cards divided by 9 groups. So here's what kids are actually doing today. Kids today are going to take what they know about base factors, and really what they're saying is 27 divided by 9. Then they say, oh, that's a fast fact I know. 27 divided by 9 is 9, 18, 27. 3, right? 27 divided by 9 is 3. But guess what? They had, look right there, 1 power of 10. So they come down here and add their 1 power of 10. And that's how they get 270 divided by 9 equals 30, right? They add that power of 10 back to fix that factor. That fact. All right, so if we come down here, it says, let's practice. What if Jose had 270 cards put into 90 boxes? And so you can tell that this equation has 1 power of 10, there's 1 0 represented. In the try one more, what are kids going to actually see? 1 power of 10, 2 powers of 10. So I'll dive into this with you. So I've got 270 divided by 90 equals, which is my total, divided by my number of groups should give me my amount in each group. So what am I looking for? I'm looking for how many cards are in each group. All right, do a little auto imaging, see if this helps. I got some feedback that you couldn't always see the work. Okay, so my total, I'm looking for the amount in each group. So I can do my fast fact, which is right here, 27 and 9. 27 divided by 9 equals, I know this, 9, 18, 27, right? 27 divided by 9 equals 3. But I also have 1 power of 10. Make sense? Yeah, right? I got that power of 10, so I bring that down. 1 power of 10, 2 powers of 10. Does that work? So kids today are going to be asking themselves, wait a minute, was I supposed to add my powers of 10 there? No. Here's what gets tricky about it. You have to see if the powers of 10 cancel each other out. So instead of this being 27 divided by 9, it's actually divided by 9D. The power of 10 on this side of the division side actually cancels out the power of 10 on this side of the division side. This side of the division side. So, because the powers of 10 cancel each other out, my answer is actually going to be 3. If I were to take 90 plus 90, I'd have 180. And add another 90, I'd get 270. So kids have to be careful when they're doing powers of 10 today, that if there's a power of 10 on the left side of the division sign and on the right side of the division sign, they cancel each other out. I know, it can get tricky, which is why we're not going to spend too much time in this power of 10, and we're going to start doing division in a little bit different way. But here we go. So let's try one number for the workshop just to make sure you guys are clear. They would do 280 divided by 7. They go base factor, 28 divided by 7 equals, and they might do their 7s, 7, 14, 21, 28, that's fine. 4, they check to see how many powers of zeros on the left. 1, any on the right? No. So they're 1 power of 0, 1 power of 0, their answer is 40. Show how you know. 28 tens is 280, divided by 7 equals 4 tens, 40. So it would look like this. So this is 280. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, right? They did 28 tens. So you would do 7. 1, 2, 3, 4, 5, 6, 7, right? So they would do like, I want to divide that into groups of 7. So there's one group of 7. 1, 2, 3, 4, 5, 6, 7. 2 groups of 7. 1, 2, 3, 4, 5, 6, 7. 3 groups of 7. 1, 2, 3, 4, 5, 6, 7. 4 groups of 7. So 28 tens divided by groups of 7 gives me 1, 2, 3, 4 groups of 7. So what they're trying to do in workshop today is actually get kids to understand that that power of 0 means that I don't have 28, I have 280 tens. And I want to put that into 7 groups. So that means if I did 28, so 2 tens and 8 ones, and divided that into 7 groups, I get 4 per group. But now I have 28 tens. I'm dividing 28 tens into 7 groups, and I get 40 per group. So that's what workshop looks like today. Kids might actually, when they try one on their own, fast fact, 64 divided by 8. Fast fact is 8. Power of 10 on the left, power of 10 on the right. So it stays, what? 8, yeah, because it's actually 640 tens divided by 8 tens. We could try that like that. We could do how many tens? 8, right? And 8 in each group, so let's try it. 10, 20, 30, 40, 50, 60, 70, 80. That's one group of 8. 10, 20, 30, 40, 50, 60, 70, 80. And if they wanted to, they could do that all the way down. So we've got 80 plus 80. I already know that's 160. I would keep going, keep going, keep going. So I would do that. I know that this is 2, 4, 6, 8. If I were to just keep doing that down, I get 160 plus another 160 plus another 160 plus another 160. If I were to add that quickly, I would know that's that. 6, 12, 18, yes, 24, 2, 3, 4, 5, 6, 640. So it's tricky on how kids are showing their work today, this representation. I think the biggest bang for your buck is if you really make sure that they understand that the power of tens on the left and the right cancel each other out. This is, in fact, 280 tens in 7 groups. This is 640 tens, not in 8 groups, in 80 groups. So that's the hurdle and biggest gap that I think kids are going to have with the lesson today. There we are, Unit 4, Lesson 10.